During 2025, I had the opportunity to record behaviors that few get to see. In this video, I have gathered my 7 best videos of the year. Get comfortable, because this starts now. This Camponotus ant, also known as the giant forest ant, has discovered a trail of sweet sap and must hurry to feed, as other creatures with the intention of claiming it will soon arrive. Their rivals, the garden ants, are their feared neighbors. At the slightest hint of food, they can appear by the thousands, easily outnumbering these imposing Camponotus. Both species require large amounts of protein and compete fiercely to capture prey during these hot summer months. Although the giant ant was the first to find the loot, a garden ant is already trying to steal it. She must use all her strength to transport it quickly into her nest, where the larvae eagerly await their meal. Camponotus ants can carry and transport objects that weigh many times more than themselves, with a typical carrying capacity of about 10 to 50 times their own body weight, allowing them to move large prey and insects to feed the colony thanks to their strong muscles and robust exoskeleton. Fortunately, she is not alone in the daily task of foraging, and since her food is close to the nest, reinforcements will soon arrive to help her. They know that dozens of garden ants could appear at any moment, so it is crucial to reinforce their presence and coordinate their movements quickly. Each colony member has an important role. Some carry the prey into the nest, while others watch the surroundings, alerting to any threat. This coordination demonstrates how even the largest ants rely on cooperation and collective strategy to protect their resources and secure food for the colony. Communication among these ants is remarkably efficient. They use pheromones, antenna taps, and vibrations in the ground to convey information about food sources, the presence of threats, or the safest routes, ensuring the entire colony acts in a coordinated and swift manner. The mission seems to be unfolding successfully. They have managed to keep the prey away from the dangerous and numerous jaws of the garden ants, which could have snatched it in seconds. Thanks to their coordination and collective effort, without a doubt, today is a great day for this colony, quietly celebrating their victory and the skill of each member in fulfilling their role within this complex society. Near the nest, a wasp colony waits patiently for one of its workers to return with food for the colony. However, the return is taking longer than usual, creating tension among the others. 2 Camponotus soldier ants, during their daily hunt, have managed to capture the wasp. The younger ant holds it firmly, while the veteran tries to subdue it with strategy and strength. They likely found the wasp already injured, taking advantage of the opportunity for an easy capture without much effort. However, what the veteran doesn't know is that something terrible is about to happen. An unexpected twist in this hunting scene could jeopardize the operation, and every move of the colony will depend on the speed and coordination of its members to face the looming threat. Both are somewhat far from their nest. When food is scarce, they have no choice but to venture into less explored areas, which significantly increases the risk and forces each member to stay alert while carrying out their mission. Pay close attention to this unusual behavior. The veteran is so focused on subduing the wasp that anger takes over, and without realizing it, she ends up biting her own companion. If you watch closely, you will notice a garden ant emerging stealthily from behind the scene. What happens next will change the course of this hunt. This small worker is about to alert her entire colony. She knows both ants are alone and completely unprotected, with no chance of help. And in that moment, the balance of power shifts, giving the enemy colony the perfect opportunity to claim the prey. The danger of these ants lies in their sheer numbers and remarkable coordination. They are expert hunters, capable of capturing even other ants. The veteran senses that something is amiss and prepares to deter the tiny intruders, ensuring her companion can safely carry the food back to the nest. At any moment, as expected, the situation worsens. The garden ants manage to seize the prey and carry it to their territory. Meanwhile, the furious veteran Camponotus tries to reclaim it, but she has made a critical mistake that could cost her dearly. She defends herself as best she can, but there are simply too many. Even so, she keeps fighting without retreating. Garden ants attack in groups, biting in a coordinated manner and clinging to the body and limbs of their opponent, using their numbers as their main weapon to overwhelm prey much larger than themselves. Within seconds, she is dragged by a tide of tiny ants trying to overpower her and pull her into the depths of their nest. However, she will not make it easy. This Camponotus is built to endure. With a robust exoskeleton, extraordinary strength, and exceptional mandibles capable of keeping her standing even when vastly outnumbered. The coordination and the attack are brutal. The giant ant has just realized that continuing to fight to recover the food is impossible. And now all she can do is try to escape as best she can, surrounded by an enemy that shows no mercy. Pay close attention to these incredible images, which show how these ants coordinate with precision to subdue their opponent, strategically targeting the limbs, perhaps the only truly vulnerable point of this veteran ant. For a moment, it seems like the end has come for this ant, trapped and overwhelmed by her rivals. But suddenly, something unexpected happens. She finds strength where there was none left, pushes with determination, and little by little manages to move away, refusing to surrender even in the most unfavorable situation. She finally manages to break away and lose the tireless army of tiny ants, beginning the return to her nest after one of the most dangerous encounters of her life. She is somewhat disoriented, but these ants possess an astonishing ability to navigate. Thanks to root memory, the use of visual landmarks, and the pheromone trails they leave behind as they move, she is able to remember the way back even after a chaotic situation like this. Regarding the lost prey, it is finally being transported into the soil, a place from which it will never return. There, it will serve as food for the next generation of larvae, which rely on this protein for their growth and future. Finally, the veteran ant has managed to escape and enter her own territory, where the sun is already setting and most of her sisters are waiting inside the colony, safe and ready to continue with their tasks. The day has been tough for her, and now it's time to rest and recover. Tomorrow will be another day just like this, full of work and challenges. This has been simply another day in the life of an ant. In the midst of the hot summer, something unexpected appears, drawing all the insects. This tree is releasing a large amount of sap. With food scarce during this season, all the insects gather in the same spot, leading to frequent skirmishes and conflicts. Asian wasps, hornets, ants, flies, and katydids compete equally for their share of the bounty. They must hurry as no one knows how long it will take for the tree to shut off the sap tap. Sweet substances are a crucial food source for nearly all creatures, and the scent they emit attracts them from long distances. Even predators know that where there is nectar, there are prey waiting. This vampire mantis, with its extraordinary camouflage and movements that mimic a branch swaying in the wind, claims its share of the bounty. Due to its small size, it must focus on smaller prey while staying alert to larger creatures that could pose a threat. The most effective strategy is to quickly capture its food and retreat safely. Asian wasps and European hornets are the true dominants in this area, where interspecies confrontations are very frequent and shape the behavior of all the insects present. Pay close attention to this incredible moment, because an intense dispute is about to unfold. Tension causes both species to react simultaneously. Although the Asian wasp tends to be more active, the European hornet is larger and more robust, giving it physical advantages in the encounter. Both have very strong exoskeletons that protect their vital organs, making their stingers relatively ineffective in direct interactions. For this reason, their strategy focuses on using their powerful mandibles, which allow them to manipulate objects and defend themselves, demonstrating how morphology and mechanical strength directly influence their behavior and interaction strategies. The European hornet appears to have managed to knock down the Asian wasp, leaving it vulnerable to other creatures watching the scene. These encounters not only attract the attention of other insects, but also demonstrate the complex dynamics of competition and survival in the ecosystem, where every movement can be observed and utilized by different species, whether to feed or to study the behavior of their neighbors. A carnivorous beetle and a Camponotus ant are the first to encounter another wasp. For the beetle, a single ant poses no threat, but both know that if they don't act quickly, more competitors will arrive. Finally, each one takes its share. Usually almost everything that touches the ground ends up in the hands of the ants, which take advantage of any remains to transport them back to their nest. Returning to the previous wasp, it is in serious trouble, as the hornet has reduced its ability to fly. The ants have detected its vulnerability, but knowing it is not completely defenseless, they call for reinforcements. They understand it cannot go far, so they will attempt to exhaust and subdue it in a coordinated and patient manner. Camponotus ants, also known as carpenter ants, are expert foragers and architects of the insect world. Their relatively large size and strength allow them to carry food much heavier than themselves, while their extraordinary communication and coordination skills enable them to organize complex tasks within the colony, from nest defense to feeding the larvae. These abilities, along with their longevity and spatial memory, make each individual a fundamental part of the social structure and the survival of the entire colony. Notice how it tries to attack from the side, attempting to catch the wasp off guard, which is already exhausted from the intense encounters. The wasp is aware that in its current state, it will not be able to return to its nest, making it even more vulnerable as the ants coordinate their movements to limit its escape options. Although the wasp Vespa orientalis has a powerful stinger, whose venom contains proteins such as phospholipids, hyaluronidases, arginine kinases, and other neurotoxic compounds that affect tissues and nervous systems in prey or predators, it is almost impossible to hit an ant, so using it in this type of interaction is ineffective. Vespa orientalis, or oriental hornet, is an invasive species that has spread from North Africa to southern Europe and Western Asia, adapting even to hot and dry climates where few species survive. Its nest can be found in a wide variety of locations, from underground cavities to tree branches or building crevices, and can reach impressive sizes. While it feeds on nectar and ripe fruits, it is also an opportunistic predator, capable of capturing insects and other invertebrates, sustaining colonies of several thousand individuals. Interestingly, its gut microbiome varies with diet, influencing its metabolism and interactions with other insects, making it an unexpected and fascinating player in the ecosystems it invades. Notice how this tiny ant, minuscule compared to the wasp, confronts it alone, displaying bravery and determination against a much larger opponent. The Camponotus ants continue their siege with astonishing patience. After expending so much energy, they have no intention of retreating without securing their prize. They know that, little by little, they are successfully exhausting the wasp's resistance, and each coordinated movement contributes to draining even more of its energy. The confrontation drags on until sunset, as daylight fades and the atmosphere grows tense. Finally, the wasp collapses, unable to continue, and the ants prepare to transport their prey into the nest, ensuring food for the colony and demonstrating the efficiency of their collective work and the complex social organization that characterizes these remarkable creatures. Finally, the meal is served, and nature continues its course as each creature takes advantage of the opportunity the moment provides. But these small, opportunistic predators are not the only ones waiting patiently for any prey to make a mistake. In this place, there is a true hunting zone, hidden in the most unexpected corner. In this trailer, countless eight-legged creatures have made their home, weaving intricate webs that fill every corner. Every day, a large number of prey become trapped in this invisible and sophisticated web, woven with precision by its owners, the feared Steatoda, a type of spider known as the false black widow. Although their behavior is nearly identical to that of their more notorious relative, their smaller size allows them to adapt to much tighter spaces, making places like this trailer an ideal home. They have likely chosen this spot for the warmth it provides when the sun shines directly, and it is highly probable that most of them, in addition to being neighbors, are also relatives, forming a complex social structure within their territory and maximizing the efficiency of their hunting. A wasp has fallen into the trap, and it is not surprising, as hidden beneath in the shadows lies a nest with little chance of thriving in this location. Steatoda spiders have an impressive ability to produce different types of silk, using one to build the structure of their web and another, extremely sticky, to immobilize their prey, especially flying insects. When a drop of this silk touches an insect's wings, it almost completely paralyzes it, allowing the spider to wrap it precisely and transport it to a safe location. Interestingly, some Steatoda species can adjust the amount and stickiness of their silk depending on the size and type of prey, optimizing capture while reducing the risk of injury during the encounter. Additionally, the arrangement of threads in the web is strategically designed to support the weight of larger prey and withstand tension, making their web a true work of natural engineering. As is common in most interconnected webs, nearby predators are always alert and can sense the vibrations when prey falls. Therefore, this Steatoda must hurry to wrap and transport its food before a neighbor claims it, showcasing the speed and precision needed to survive in a competitive environment. Suddenly, the spider senses a greater danger and retreats, as if its sixth sense warned it that something is approaching. It pulls back momentarily while assessing the situation, carefully evaluating the risk before making a decision. It decides to continue its work and speed up, aware that something is watching. Pay close attention to this spectacular moment and the remarkable way it carries its prey. But it is already too late. Along the way, it has no choice but to release its prey, as a true black widow has entered its territory. The threat is detected immediately, creating tension and forcing the Steatoda to react swiftly. This black widow, with a large abdomen, possibly pregnant and about to lay her egg sac, needs food at all costs. Her imposing size intimidates the other spiders living in this trailer, allowing her to claim prey at will. This time, the Latrodectus seems to want more than just claiming the wasp. It could take it back to its den, but it also appears interested in capturing the small Steatoda. It tries to lure her out of her hiding spot, but the tiny spider refuses to leave, so the black widow decides to go straight for her. In the world of spiders, not only strategy but also size determines the balance of power. While this intense skirmish is silently observed by other creatures living near the trailer, something else unexpected and imminent is about to unfold at the front, adding a new level of tension to this delicate and dangerous scene. A group of Camponotus ants is collecting food within the spider's territory, an act that does not go unnoticed by these opportunists who watch every move closely, assessing the risk and the chance to take advantage of any mistake. The false black widow plays to her advantage within her territory, but she knows that a group of ants together can be dangerous. For this reason, she patiently waits for the perfect moment to catch one off guard, combining patience and strategy in every move. Notice how quickly it acts and how one of its companions detects the threat and rushes to its aid. The ants will not allow the spider to capture their sister so easily, but the Steatoda knows her prey is already ensnared in the web, and she only needs to wait for the right moment. The ants search for the aggressor, but time is running out, and sooner or later they must resume their foraging. All of this is perfectly calculated by the spider, which lives in the lower part of the trailer and is accustomed to hunting ants, possessing a deep understanding of their behavior and movements. The Camponotus ant will fight to the end, but the spider knows it must be careful of her powerful jaws, capable of defending with strength. Therefore, she positions herself at the back of the web, away from the threat, while unleashing a cascade of silk to immobilize the ant and limit its movement. More than one spider inhabits this area, and their neighbors watch the encounter from a distance, assessing the situation and waiting for the perfect moment to intervene or take advantage of any mistake. The rest of the ants continue moving around the area, but it is already too late. They must leave their companion behind and return to the nest. The world of spiders is fascinating, full of tension and deception, but that of ants surpasses all expectations of warfare. A confrontation between nests is about to unfold in another part of the forest, where Camponotus, garden ants, Chrematogaster, and other creatures will become involved and swept into the chaos. In the heart of the forest, something terrible is about to happen to the Camponotus. These ants face constant dangers. Some bear the marks of previous battles. The forest spares no one and shows no mercy, with every corner seemingly watching, stalking, and waiting for the perfect moment to capture them. This Agelena labyrinthica, also known as the funnel web spider, attempts to hunt a large Camponotus that has fallen into its web. But even though it is trapped, the task is not easy. The spider must act quickly, using its chelicerae, while dodging those of its rival, as a single strike from those powerful jaws could be fatal. While recording this event, something caught my attention. A swarm of wasps buzzed and hovered over the area. Upon closer inspection, I realized it was a dangerous zone inhabited by Vespa bicolor, another invasive species, which seemed furious, as if something had disturbed the peace in their nest. Chaos was not only taking over the air. Underground, a confrontation of epic proportions was about to erupt. The combined army of red ants, garden ants, and Camponotus meticulously prepared for battle, arranging ranks, coordinating movements, and evaluating every possible strategy. Each individual was aware of the importance of its role, defending the territory, protecting the colony, and securing vital resources in a conflict that would test their strength, endurance, and teamwork like never before seen in this part of the forest. The confrontation begins between the Camponotus and their rivals, the garden ants. Thousands of tiny jaws besiege the nest, searching for larvae with the intent of capturing them as food. Meanwhile, other insects, such as this beetle, watch closely, witnessing this historic moment and the intense struggle unfolding. The Red Army attacks from the rear, forcing the Camponotus to face multiple fronts at once. While fiercely defending their territory, they must coordinate to evacuate and protect their larvae, moving them to a safe location within the nest. Every movement requires precision and speed, as any mistake could endanger the next generation and jeopardize the survival of the entire colony amid this seemingly endless conflict. The ratio is brutally uneven. Each Camponotus must face more than a dozen enemy ants. Although their nests grow much more slowly than those of other species, nature has not left them unprotected, endowing them with great resilience and strength. The red ants employ a meticulous strategy, targeting the limbs to try to bring down these giants, fully aware that any mistake could be fatal. As the battle reaches its peak, other insects crossing the area are inadvertently drawn into the conflict. The Camponotus prioritize defending their queen and protecting the larvae, which are currently exposed and have been forced to evacuate the nest. They will not allow anything to approach, demonstrating remarkable coordination and determination in the face of the attack. Pay close attention to this incredible moment, where a massive centipede is being subdued by the determined Camponotus. The order is clear. Any detected presence must be neutralized. Although centipedes are apex predators, especially at this size, in the forest they have few options against these ants, which combine strength, strategy, and speed to dominate their prey. Centipedes are fascinating arthropods. They have numerous body segments with legs, and each limb is controlled by a segmental nervous system, allowing them to move with remarkable agility even on uneven terrain. Interestingly, some species can regenerate lost legs and use venom to immobilize their prey, although they rarely attack animals larger than themselves. As this group of ants tries to block the centipede's path, it attempts to flee, but the Red Army spreads across the area. Their nest is ancient and houses thousands of individuals, each with specialized roles that allow them to organize massive assaults or defend critical routes, demonstrating how a colony can function as a true superorganism. The battle between the colonies reaches its critical point. Thousands of tiny jaws intertwine in a display of strategy and survival. Each species deploys its unique tactics. The red ants use their numbers to block routes and protect resources, while the Camponotus defend their queen and larvae with strength and precision, showing how even the smallest insects employ complex tactics in natural conflicts. The Camponotus only need to buy time while meticulously evacuating the nest. Their goal is to withstand the assault and maintain control of the passages and tunnels, ensuring that no strategic area is left exposed. Each worker plays an essential role, showing how organization and specialization within the colony allow them to handle extremely complex situations effectively. Amidst all this chaos, an opportunistic predator emerges. A spider watches the encounter from a safe distance, assessing every movement. It patiently waits for the right moment to capture prey, taking advantage of any ant showing signs of strain. All the ants are out of control, moving rapidly and swarming anything in their path. However, the Camponotus possess an extraordinary chemical advantage. They can release a spray from their abdomen composed mainly of formic acid, along with small amounts of ketones and volatile aldehydes. When sprayed on other ants or competitors, this mixture causes immediate irritation to their exoskeleton and sensory organs, slowing their movements and creating temporary confusion, allowing the Camponotus to buy time to reorganize or escape risky situations. Gradually, the frenzy of battle begins to subside, yet the combative instinct of the ants is superior to that of any other creature on planet Earth. Finally, after hours of tension and skirmishes, the colony meticulously evacuates the nest, ensuring that every escape route and critical space is secured before retreating, a testament to the organization and resilience of these remarkable creatures. I noticed that my chili pepper plants were being eaten, and not by simple caterpillars, but by a much more dangerous and hard-to-control pest. As I watched the culprit, something behind me seemed to move. What I was witnessing was truly fascinating. A parasitic wasp had managed to drag a huge wolf spider out of its burrow and capture it. These wasps have exceptional eyesight and had spotted me just as I was about to approach and film them. They are always alert creatures and, although harmless to humans, are natural predators of spiders. Their speed and paralyzing sting make them extremely efficient and precise hunters. Parasitic wasps are not only remarkable for their hunting precision, but also for their astonishing behavior after capturing prey. They transport the spiders to their burrows or underground nests, carefully placing them in chambers specifically prepared for laying their eggs. The spider, paralyzed yet still alive, serves as a fresh food supply for the larvae when they hatch, ensuring optimal development. Interestingly, some species can select the exact nest location based on humidity and temperature, factors that maximize the survival of their offspring, showcasing a level of planning and specialization rarely seen in insects. I find it fascinating to watch how the wasp carries the spider, gripping it by its chelicerae, the hardest part of its body, demonstrating an instinctive knowledge of where it can hold securely and efficiently to transport it safely to its nest. I decided to return to continue observing these fascinating creatures with bulging eyes and distinctive faces that had invaded my chili pepper plants. Known as katydids, they appear during the hottest 2 months of summer, feeding intensively to build up energy and lay eggs continuously before the season ends. They are everywhere, invading every corner of the field. Their sound, similar to that of cicadas, is produced by 2 tiny wings located on the top of their abdomen, whose sole function is to generate this characteristic call. However, no creature is exempt from danger. Despite their size and omnivorous diet, katydids must stay alert as other species watch and keep them in check within their environment. Although often mistaken for grasshoppers, katydids are practically their opposite. Their reproductive strategy is unique. Females lay eggs coated in a white foam expelled from their abdomen, which hardens upon contact with air, protecting the eggs from predators, parasites, and harsh environmental conditions. Unlike grasshoppers, their hind legs are not specialized for long jumps, making them slower and clumsier in movement. Interestingly, many katydid species exhibit such perfect camouflage that even when motionless on dry or green leaves, they can remain completely unnoticed by predators. Their appetite is so voracious that katydids will feed on almost anything, including leaves, flowers, small insects, and even members of their own species when opportunities arise, a behavior known as opportunistic cannibalism that helps them survive during periods of food scarcity. Among the favorite plants of these insects, other creatures take advantage of any opportunity. Here we observe a tiger spider alongside its male. The size difference is striking, as the male is much smaller and rarely hunts on its own, relying instead on prey that falls into the female's web for sustenance. In this environment, nothing is safe from danger. Observe this remarkable moment. A tiger spider, perfectly camouflaged among the lentisk shrubs, displays exceptional skill and speed in both handling its web and preparing its prey. Any creature that collides with its threads becomes trapped, and their appearance perfectly coincides with the peak activity of katydids, making encounters frequent and strategically advantageous for the spider. Many of the katydids, when moving from one plant to another after consuming an entire one, find themselves confronted by these lurking spiders. The Argiope lobata, known as the tiger spider, constructs highly precise and resilient orb webs, with a radial pattern reinforced by thicker threads for added stability. These webs are not only used to capture flying and jumping prey, such as katydids, but also allow the spider to detect the slightest vibration, pinpointing the exact location of any insect that contacts the threads. Argiope lobata has powerful chelicerae capable of quickly immobilizing its prey through a bite, followed by wrapping it in silk, ensuring the food is securely held while it is processed. This behavior demonstrates a combination of mechanical precision and evolutionary adaptation that few spider species achieve, explaining why these spiders are such effective predators in their ecosystem. Among the plants, another predator watches patiently, studying every movement of its prey, the praying mantis. This insect, known for its characteristic praying posture, is an extremely efficient predator thanks to its binocular vision and large compound eyes, which allow it to perceive depth and accurately calculate the distance to its prey. Its front legs are adapted to quickly and firmly capture insects, using spines to immobilize the victim before consumption. The praying mantis not only hunts using its natural camouflage among leaves and branches, but it can also rotate its head nearly 180 degrees to monitor its surroundings and detect potential threats or prey from any angle. Additionally, some species exhibit selective hunting behaviors, choosing prey based on size and risk, demonstrating a level of adaptability and efficiency that makes it one of the most fascinating predators in the terrestrial ecosystem. In the higher areas of the forest, another creature takes center stage during these hot days, the cicada, whose characteristic and deafening song fills the summer air. These insects spend most of their lives underground as nymphs, feeding on the sap from the roots of various trees and plants, providing the nutrients they need to grow and develop over several years before emerging. Upon reaching the surface, they molt and become adults, dedicating their time primarily to reproduction and attracting mates through their powerful stridulation, produced by specialized organs called tymbals located in the abdomen. Their song, besides attracting potential mates, can also signal their presence to other cicadas and indirectly influence the behavior of nearby predators and insects. Though they may seem vulnerable due to their size and noisy activity, their life cycle and adaptation to the environment make them essential protagonists in the ecosystem, providing food for birds, spiders, and other predators while fulfilling a crucial role in forest dynamics. Near this area, I came across a small abandoned wasp nest whose survival seemed destined to fail, as it had fallen from the trees. I decided to collect it, care for it, and protect it for a while to study it, with the intention of later returning it to a safe location. When a wasp nest is young and contains only the queen or a few individuals, the wasps are not aggressive. Despite having a stinger, they rarely use it defensively. Their diet mainly consists of sweet substances, such as nectar and sap, which provide the energy needed to keep the queen and workers active, as well as to incubate and feed their larvae. Additionally, these wasps use other insects as food for their offspring. They hunt small prey, paralyze it with their venom, and transport it back to the nest, where it is deposited alongside the larvae. The development of the larvae usually takes between 2 and 3 weeks, depending on the species and temperature. Surprisingly, when they emerge, the young wasps are almost the same size as the adults, though they lack the strength and skill of their mothers. Few people know that some wasp species have remarkable visual memory. They can recognize faces, identify other members of their colony, and remember the location of food sources, which allows them to optimize their movements and resource collection. Thanks to these cognitive abilities, even a small nest can survive and thrive for weeks, provided it is protected from predators and environmental hazards. During my time caring for this small nest, I observed their behavior in great detail: how the queen inspects her home, how the workers feed the larvae, and how all of them coordinate calmly and efficiently to maintain the integrity of the colony despite their small size and apparent vulnerability. As the days passed, I continued observing the small wasp nest, and their behavior became increasingly fascinating. The queen remained calm and surprisingly gentle, moving slowly and deliberately as she inspected her nest. I made sure to provide enough protein-rich food for the developing larvae, allowing them to grow quickly and stay healthy. With each passing day, it was incredible to see how much they changed. The larvae became stronger, more active, and more responsive to the care provided by the queen. Their movements became more coordinated, and their reactions to environmental stimuli more precise, revealing the innate abilities of these tiny yet highly capable insects. Eventually, the first new worker wasps began to emerge, completing the initial growth phase of the colony. These young workers, although smaller than fully mature individuals, immediately took on responsibilities within the nest, feeding the next generation of larvae and assisting the queen. Observing this development firsthand was both humbling and enlightening. I witnessed how a tiny, seemingly fragile nest could become a fully functional colony through meticulous care, cooperation, and natural instincts. Each day brought new insights into their social structure, problem-solving abilities, and the subtle ways the queen and her workers interact to ensure the colony's survival and expansion. In the early days of the colony, activity may seem limited, but every gesture of the queen and the few workers has a purpose: to keep the brood safe and lay the foundations for future organization. As new workers are born, the social structure becomes richer and more diverse. Some focus on gathering nectar and prey, others dedicate themselves to cleaning and repairing the nest, while a few explore the surroundings, learning routes and hazards that the colony will need to know for survival. What is most impressive is that these wasps possess uncommon cognitive abilities. They can recognize elements of their environment, remember routes, identify intruders, and distinguish their nestmates even in complex and changing spaces. Thanks to this ability, the colony optimizes larval feeding and distributes tasks in a way that every action directly benefits the survival of the group. Watching these wasps interact is like observing a living system of almost mechanical precision. Each insect knows when to act, how to respond, and what decision to make, forming a social web where cooperation, learning, and communication are intricately intertwined, demonstrating that the life of these small societies is full of strategy and sophistication. After taking care of them for a few days, I decided to return to the forest to release them back into their habitat and continue observing other creatures. That's when I came across a rarely seen species, a macrothele, a massive, impressive spider with large and robust chelicerae. It's unusual to see it outside its refuge, wandering through the forest. It was likely searching for a damper, darker spot to establish a new safe shelter. The macrothele spiders are fascinating and long-lived, capable of living several years under optimal conditions. Unlike many spider species that constantly move around, these spiders prefer to establish a fixed shelter, usually in humid and dark areas, such as cracks in rocks, fallen logs, or under leaf litter, where they build complex silk webs used both for protection and prey capture. Their diet is primarily carnivorous, capturing insects and other small invertebrates that come near their web. Their large size and robustness allow them to hunt prey bigger than what other spiders in their environment can handle. A surprising fact is that their chelicerae, besides being used to immobilize prey, are strong enough to pierce the exoskeleton of beetles or other hard-bodied arthropods. Macrothele reproduction is equally interesting. Females can lay several hundred eggs in a protected sac inside their shelter. Unlike many spiders, the females exhibit some parental care, guarding the sac until the spiderlings hatch. The young are almost identical to miniature adults and begin to disperse once they have developed enough strength and skills to survive independently. These spiders display cautious and highly observant behavior, using their long legs to sense vibrations and movements around them. Although territorial, they rarely attack larger predators unless directly threatened, preferring to retreat to their shelter. Their presence in the ecosystem is crucial as they help control insect populations and maintain the forest's natural balance. Observing a macrothele in its natural habitat reveals a world of precision, patience, and strategy. Every movement is calculated to maximize survival and hunting efficiency, showcasing the sophistication of these giant spiders and their vital role in the forest ecosystem. Returning to the topic of katydids, as I approached one of their favorite plants, I witnessed a fascinating and surprising scene. Cannibalism among these insects was taking place. Although they are primarily herbivorous, feeding on leaves, flowers, and sap, during periods of food scarcity or when an opportunity arises, katydids do not hesitate to consume individuals of their own species. This behavior provides an immediate source of protein and nutrients, especially important for young males or growing females who need to develop reproductive organs and musculature. Cannibalism does not occur randomly. Generally, individuals target weaker members, freshly molted ones, or those that are distracted, and competition among them can be intense, as the first to secure the prey gains significant nutritional benefits while the others must wait or find another food source. Moreover, this behavior has evolutionary implications, as it favors the survival of the strongest and most agile individuals, selecting traits that enhance speed, strength, and sensory perception in the species. What is most curious is that, despite their harmless appearance and their song that resembles cicadas, katydids exhibit a flexible behavior that combines herbivory with occasional intraspecific predation, showing a remarkable adaptation to the limited resources of their environment. Something few people associate with these beautiful and seemingly peaceful insects. In the forest, the fall of any insect does not go unnoticed. This seemingly simple event triggers a storm of activity among predators and scavengers inhabiting the ecosystem. From tiny ants to camouflage spiders and opportunistic beetles, all sense vibrations in the ground, changes in the air, and chemical traces that reveal the presence of potential food. Each creature reacts according to its abilities. Ants coordinate precise attacks, transporting pieces of prey back to their nest. Spiders assess the size and danger of the prey before intervening, using their webs strategically. And carnivorous beetles take advantage of any distraction to claim the remains. This moment, seemingly simple, transforms into a complex web of interactions, where competition is intense but governed by instincts that ensure the survival of each species. It is a reminder that in nature, even the smallest act, a single insect falling to the ground, can unleash a choreography of survival, strategy, and adaptation, revealing the collective intelligence and unique skills each creature has developed to thrive in a world where every resource is vital. Summer is coming to an end, and with it, the frenzied activity of many insects that have populated every corner of the forest for months begins to decline. Those without adequate shelters succumb to temperature changes, humidity, and the first rains, while the adapted insects with protective structures or strategic behaviors manage to survive and await the arrival of the next season, showcasing the incredible adaptability these small creatures possess.